We have two examples here of sinusoidal graphs, and both of these examples by the graph is the same. What we're going to talk about now is if you're given the graph, how you can write the equation, as opposed to yesterday where you were given the equation and had to do the graph. So the first thing to start with is to always figure out where your equation of the curve is. That's what's so helpful. Let me just make this different color here. So our equation of the curve right here is always what goes through the middle of the sinusoidal graph, and you know you have it in the right place if your peak and your trough are the exact same distances, the exact same measurement. So in this case, my peak from my equation to the highest point is 1, and my trough from my equation to the lowest point is 1. So our amplitude always goes into A. So we know we have an amplitude of 1, so we don't even have to show it. So we can go right into our sine graph here. Our other reason of figuring out where our equation of the curve is to figure out our vertical distance up or down. How much the graph has moved up or down. And in this case, it hasn't. Okay, so it has a Q value of 0. But what helps us as well is right here, right, that point right there, that was the y-intercept that used to sit at the origin. And so that can help us to see how much the graph has moved left or right. So in this case here, the graph has moved left this many units. So to me that looks like that's halfway between 0 and negative 90. So it has moved left 45 degrees. So let's put that into our graph. So we have K theta plus 45 degrees to represent that it went left. And that's the end there. We don't need to show the Q because it went up or down 0 units. The equation of the curve sits right there at 0. So the only thing we need to check for now is our K value. And as long as our K stayed still 360 degrees for one cycle, we know there was no compression along the x-axis. So I'm just illustrating right here the break. This is one full cycle. So from negative 45 degrees all the way over here, that looks like that's about 305 degrees. So if you add those together, this cycle is still 360 degrees from the point over here on the left, negative 45, all the way over here on the right. So our K value as well stays as 1. So our final equation looks like theta plus 45. Now it's important to realize that over here we have the exact same graph, but if you were asked to write it as a cos equation, you still can. You just have to keep in mind that your cycle starts here and goes down and comes back up. So it would come up to about there to finish that cycle. So our peak and our trough, doesn't matter what graph it is, it's still from the highest point to the equation of the curve, right there, from the highest point to the equation of the curve. So our peak and trough is still 1 unit, that's still our amplitude, an amplitude of 1 unit. Here, we know that K, it still has a full cycle of 360 degrees. So from there to where it would finish over there is 360 degrees. So we just have to figure out how much left or right it moved. In this case, our cos graph went right, and it went right 45 degrees from there to there. So we have theta 45 degrees. And again, our equation of the curve says how much the graph moved up or down, and it didn't. Our equation of the curve here, right through the center, still happens at y equals 0. So those equations there are finished. Let's look at this example here that has a little bit more to it. Our last one didn't have that many components of A, P, Q, and K. So in this question here, if it asks you to write an equation for y equals sine theta for a sine graph, not a cosine graph, we need to be sure that we find the closest starting point to the y-axis and label one cycle. So that's what we have right there. That's one cycle of a sine graph. So once we have that, we can actually start to do some work. Step 1 is to always find your equation of the curve. Your equation of the curve is your Q value, and it's the line that goes right through the middle of your sinusoidal graph. So what happens there? We have y equals -3. So our Q value we know is -3. Now your amplitude is always your height from your equation of your curve to your trough and to your peak, how high it is. So our A here has 1 unit. After that, we need to see how far the y-intercept moved from the axes here. So we want to see what our phase shift was to this point. So what it looks to me, if we look up here, that had a phase shift of 60 degrees. And that went 60 degrees to the left. So our p-value was 60 degrees to the left. And I find it easier to organize all of my letters first and then substitute into my actual equation. So now all that I have left to do is figure out my k. So my k means how long it took to do one cycle. So from there, so that's from -60, and here is to 120. So if we went 60 degrees there and 120 degrees there, that cycle is 180 degrees in length. So to figure out our k value, we always take the length of the cycle and divide it by 360 degrees. So therefore, my k value is 1/2. So all we have to do now is substitute everything into the equation. We have an a value of 1, which we don't represent. Then we have sine 1/2 brackets theta plus 60, because it went left, and up 3 units. And that is a full and complete equation for sine theta. Keep in mind that would be much different if you were writing a cos graph, because you'd be starting at different points for your phase shift. I'm going to clean my graph up just a little bit to illustrate one last thing with this graph that will be important in our next question. So here what I need to identify once more is one full cycle. So that's right there. And what I just want to remind you, draw your attention to, that our graph is formed into 4 equal parts. The sinusoidal graph of equal distances. That's like your key points with your base graph. So you can see how they're all equal distance apart from your equation of your curve. Make this even more clear. Through there, there, and there. This was actually done with a ruler. All of these sections are equal distance apart. One cycle can always be broken into those different 4 components. And keep in mind, it's because of that arm that we're actually measuring that's moving on your Cartesian plane to 4 equal sections that's there. Okay, that being said, this is what this section here just says. If you wanted to add it into your notes, it says that the cycle for sine theta or cos theta can be broken into 4 parts of equal length using the key points. In other words, the key points are all an equal distance apart. We can use that fact to complete a graph for which we have limited information. So let's look at this example here. It says to determine the equation of a sinusoidal function with a maximum of 90 and 4 as your point. Now it's important, and it can be as rough as mine is here, to always do a sketch to illustrate what it is you're dealing with here. So it says that my first point happens at 90 and 4, not 40. So I'll just fix that real quick. At 90 and 4. So that's where my first point hits. Then it says I have a minimum value, so about equal distance apart here, 90 degrees, 90 degrees, at 180 and 1. So there's another point right there at 90 and 180. Okay, so this one's at 180 and 1. Now we know that if this is our highest point and this is our lowest point, then our equation of the curve must happen at 2.5, because it has to be right in the center of our highest and lowest point. So our equation of the curve happens at 2.5. So then the point that's on the equation of the curve is going to be halfway in between these two. So there's 90 degrees in between here. So at 45 degrees, so this would be 135, is the point that sits right on the equation of the curve. And then here, the other point would be at 45. So we know because they're all broken into 4 equal parts, there's 45 degrees there, 45 degrees there, 45 there, and then here as well. So I was able to sketch one full cycle. So that would be at 225 degrees, just on the basis of the little bit of information they gave me and knowing that they divide into 4 equal parts. So if I wanted to write an equation of the curve, first of all, I start with my amplitude. My amplitude is from my equation of the curve up to the highest or lowest point. So there, my amplitude is 1.5 units away for each peak and trough. So as an amplitude of 1.5, it has an equation of the curve at 2.5. That's the Q value. Next, we can look at our phase shift. So for our phase shift, we want to see how far this point moved from the y-axis, that y-intercept. So that went 45 degrees to the right. The last thing we have to figure out is our K value, and we just need to know how long a cycle is for that. So from here to here, that cycle took 180 degrees to go from a starting spot up, down, and back up. So that's 180 degrees. So my K is always the degrees of the cycle, my period, divided by 360. So my K here, again, is 1/2. Now don't forget, after all that work, to actually write the equation. So we have sine 1/2 theta, and this went to the right 45 and up 2.5. So there you have your final answer to that question. We'll do more practice together in class tomorrow.